Okay, I'm gonna go from there.
Cool. Cool. Welcome everyone to another Docker Meetup. Thanks for joining us. It's our third meetup for the year, which is like awesome. We're getting like good reviews from Docker themselves about how often we're having it, and they liking the fact that the community is growing. So it's thanks to guys like you who are attending. It's awesome. And yeah, so we have some special times now. So the last meetup we had Claire, the guys are here, just brilliant from DigitalOcean. It's not every time we get people of that caliber talking to us. And today is no different. We got Gianluca, who's the Docker captain, and most guys familiar with the Docker environment. Captains are special.
That's a lot. Thank you.
So they are like the Docker experts that are not Docker employees. So that's how become captains. So people that Docker relies on to get good information, to help implement their technologies, but they don't really work for Docker.
Yes.
So that's the captain. Yeah, so Gianluca from Italy, enjoying his African sun, as you can see. And yeah, so he will give us a great talk on Kubernetes and other stuff. And so for the guys here for the first time, so basically the meetup is very casual. So we start off with like our talk, our presentation, we have some different presentations, but it's like, it's all about learning. It's all about sharing our experiences. So even after the presentation, if we have a Docker question that's not what we talked about, we should pose it to the floor, we will answer, because your issues might be common, and your successes other people might want to learn from. The whole idea of the meetups and the Docker is to build a community, that we share our knowledge, so we grow together, and we are better, in our daily job and at home. Because we have a lot of good home projects as well. The guys are working on using Docker. So that's quick for now. Gianluca can maybe
Yeah, I really like the mood of the meetup. Getting better together is important, and it's a fundamental piece for me and for the Docker community and for everyone that works in open source or with open source technology. That's how we grow. We grow with the community. We grow learning and speaking with each other. So it's great to have meetups, and I'm very happy to be here to speak with you. So let's kick this out. I work as a site reliability engineer at Inputs Data. So I'm going to speak about what Inputs Data is and what we do later in the slides. But as a site reliability engineer, we have a SaaS offering, and I try to take it reliable. So I write the automation, I measure what's going on in our SaaS, and I try to keep stuff boring for the other member of the team. So I blog. I try to blog once a week. Sometimes it's more, sometimes it's less. It really depends how I'm good at. You can find me around the net as a Janar, on Twitter, GitHub, whatever you want. So just keep in touch with me. Other than that, I like to make dirty hacks to look great first. I'm really good at that, so my hacks are great. So I grow my vegetables. So I have a garden in Italy where I grow tomatoes, salad, and whatever. So I can't wait to come back because it's finally the season, so I get started again. And I like to travel for fun and work. So when I can combine them together, like here, where I have a bit of time to enjoy the city and the sun, and also some work to do, it's great for me. So thank you for having me here. I made homemade pasta, and this time homemade gnocchi. When I moved to Dublin from Italy, I missed the Italian food, so I learned how to cook by myself. So my grandma was very proud of me. This is me. This is the place where we had the all hands meeting in this year in Inputs Data. So we are used to have a company meeting because we work remote. So we went all together in California. This time was there. So really good. This is here. So yesterday I was at the LinuxCon. So this is the LinuxCon. I thought it was. It's a great community over there. So you should be proud of them. And this is me in Cuba. as you can see, I'm much bigger than the horse itself. This was my first ride. So when I say to them, oh, this is my first ride, so they give me the little. That's good. That's good. Yeah. So let's come back on what we do as a company. Influx Data has a set of open source tools to do monitoring. So everything started with InfluxDB. InfluxDB is a time series database. So it is a database like just MySQL, MongoDB, or whatever, but it's specialized to work with time series data. And time series are data that matters over time. So if you think about logs without a timestamp doesn't really mean anything. So that's time series. Because over time, something changes. All the IoT space where you have sensor, temperature, humidity, and all this kind of stuff, without time, it doesn't have any sense. You know the temperature, but you don't know when it happens. So when it happens, it's useless. Same for DevOps. In the DevOps space, we have a lot of monitoring because CPU, memory usage, IOPS, everything is in time. So time series database, that's what it means. It's a database built for that purpose. We did that, and after that we realized there is a lot more than the community was asking for. So we built Telegraph. Telegraph is another open source collector this time. So when you have DB, you need to push data inside DB. So Telegraph is made for that. It's a single binary in Go that has more than 200 input values. So you can, when I mean input, it's made of plugins. There are different kinds of them. Inputs, so get data, how to get data in the system. And output is where to put data when it goes out. Obviously, one of the output plugins is InfluxDB, but as an open source project, it can push data to a lot of different things. Kafka, Graphite, Prometheus, a lot of them. So you can check that. And there are, as I said, more than 200 input plugins. Docker is one of them, and we're going to see how it works later. So that's it. You configure it and you target your database. After that, we built Capacitor. Capacitor is a proactive stream processing of batch processing. So you have all these data, but what to do with them? So usually you do alerting, and Capacitor is able to do that. So you can say, every 10 minutes, give me the mean of the RAM, or the sum of the RAM, and if it's more than a threshold, send me a Slack message or call me via PagerDuty or whatever. So, and other than that, it's also able to apply math on the data you have. So you can apply machine learning algorithms. Chronograph is the visualization. You can use Grafana if you already use it or are familiar with. It supports InfluxDB by default, but we have our own one that is built for the purpose of putting all these tools together. So you can write InfluxDB queries, but you can also write Capacitor scripts and make alerting. So this is it, and check it out and try. So my talk is not all about Kubernetes. It's about extendability. Because I think the key point when I think about DevOps or when I implement automation, without that in mind, tools are just tools. So CLI tools are just CLI tools. We are the people that takes all this stuff and they put them together. We as DevOps, I don't know what to do, but I know some of them. But the idea is that you understand how your team, how your company works, and you select the right tools. And the right tools usually have APIs, and you combine those APIs to have the flow implemented as they wish to use it. But this is what I like from my job, make other people comfortable. So why Kubernetes is so powerful and why everyone is moving to Kubernetes? This is a question. Why Amazon is so expensive? This is another one. So we are in the US and we don't know why it's expensive. So this is another question. What do you do to justify all the costs that you have when you onboard a new tool? It can be Kubernetes, it can be a new cloud provider, it can be Terraform, but what do you do? It's a cost. Onboard the new tools, it's a cost. And as a DevOps, our job is to onboard the right tool that we need. It's not to deny them, because we can't deny the future. They are all great tools. We need to move fast, we need to go where we need to go, but we need to be careful. So how do we justify the cost? Do we justify the cost of AWS opening the console and clicking around as a crazy people and trying to figure out what to do? This to me doesn't really look like a justification for the right one. Do we justify Kubernetes parsing giant YAML files and putting variables inside? I don't even remember if this is a Kubernetes or an Ansible.
Kubernetes.
Yeah, it's Kubernetes. It's the version. I was just joking. I said Kubernetes because last time I gave this, I gave a similar talk with these slides, and I was emotional, and I wasn't really able to understand that. It was a really great joke, so I'm gonna use it every time. So do we really justify Kubernetes or Ansible or whatever tools we use? Writing YAML has a crazy person that gets so long that gets unmaintained. This is what we think we should do. I don't think this is the right answer. So API are the key of success. And API, in my opinion, are the key of success for Kubernetes, they are the key of success for AWS, and they are the success of Docker. So this is my goal. So I know because we had a great chat before coming here that you are all kind of using Docker in some way, or you're willing to use it in some way. So I have a lot of use cases that I worked on with Docker that they are different, and I hope that this will kick out the conversation. So this is if this is a casual meetup, this talk is going to be a very, very casual meetup because I put together some slides from random experience, and we're going to go over them together and see if we can figure out what I did wrong, what I did good, and what we can do. So this is the mood of the talk. Be aware of that. If you open, probably this is very old. I don't remember what it took it, if it's still in documentation. But this is when you do Docker architecture on Google, then this is what you get. So this is the image. I didn't do this. The Docker people made it. So it's like onion. When you have the Docker CLI, that is when you type Docker in your laptop, that's what you're using. But under the hood, you reach a REST API, and because there is a server, so there is a Docker D version of Docker. So Docker is the client, and Docker D is the version, is the server that you use. But when you communicate with Docker by default, you communicate over a Unix socket. So you don't go over TCP, you don't go over the network. It's just socket to file in your laptop, and you reach to it. So that's it. Nothing more than that. And in these big onions, you have a lot of stuff and layers, and you have data volumes. So you use that when you do Docker run -v, and you mount volumes. There are a lot of different volumes that you can use. Usually, locally in our laptop, we use the bind volume. So take my directory and share my directory. But when you are on cloud, maybe on AWS or on Google Cloud, you use block storage. So you don't mount your volume in your laptop, in your disk, but you mount something else. Obviously, Kubernetes manages that and mounts volume for you and shared volume. So there is a lot going on, but there is that abstraction. Network is another one because usually we use overlay, but there are a lot more. In AWS, there are VPC, and there is a project that brings the VPC network in the container layer. So when you are in AWS, you can use VPC as a network. So container is one, and image is one. When we pull and push images, it is all that abstraction. Inside Docker D, there are a bunch of other stuff. So if you think that Docker D is a single binary that does everything, you're wrong because there are other stuff inside. So Docker D reached to container D, that is the runtime container keep alive guy. So Docker at some point was so big and so smart that they need to split it up. So they decided to create a small binary called Docker D, and Docker D is the one that manages the life cycle of the container. So when you do run, stop, kill, almost like you do in process inside, all this kind of stuff are managed by container D. Plus some other stuff like pull and push. Obviously, the Docker D layers enrich that with what we call friendly API. So everything that is related to Docker and the CLI, it's in that layer. Container D is made for extendability. So if you look at that project, you see that it went donated to the CNCF, the Cloud Native Foundation, a few years ago, and just a couple of weeks ago it got graduated. So it's a stable project there, like Kubernetes and Prometheus. And if you see the organization on GitHub, that is GitHub/containerd/containerd, you will see that it's a really democratic place with big companies like AWS or IBM and Docker itself. They are working together to standardize a set of features to run containers. So Containerd is a really good experience about how to make something that is extensible and embeddable for something bigger. One of the implementations is Containerd, and we see it's Docker itself that uses it. But if you're building something that requires a subset and you need to empower this subset of features with your stuff, you can use Containerd by yourself. If you're gonna you can go even deeper down the stack and you can use runc. So runc is a binary, so it's daemonless. All we see here is it has a daemon. So Docker D is a daemon, Containerd is a daemon in your interact. Runc is just a CLI with a library, and it's the tiny binary that is able to translate the request that you do to having a container to a container. So it brings together C group, namespace, and all this kind of stuff, and makes it something that looks like a container. So this is it. You can go down the stack a lot more. We are gonna go there later, but this is it. And this is what I mean with extendability. At some point, your project grows that much that you see the value about just using a small piece of that, because you can give that back to the community, or you can give them out to other companies that will help you to make it more stable. So this is what happened. When Docker released Containerd, they made that for themselves, because the main problem at the time, a few years ago, when they did that, was that during the Docker restart, all the container was going down, but they didn't have shim, the process was the same, so they decided they was trying to solve that problem. And that worked really well for a year, but after a year they realized there is a lot more in the container space, because everyone was on board on that, everyone started to use that, so they integrated Swarm, so the clustering part, and Docker D was becoming too big to be just a container. So Containerd. And this is the architecture behind Containerd. I just copy paste that from containerd.io, so you can go there and check it out. But this is Docker D. It's a great extendable architecture. So if you are looking to learn how to build a software that works and it's used everywhere in the world, you should look at that. So I'm not gonna go over all of this, but Containerd exposed a gRPC API. So gRPC is like a binary protocol that because it doesn't go to the outside. It's designed to stay in the server, so binary is enough. There is a client. There are a bunch of clients like the CRI API that use that. The CRI API it's not a client, but it's a bridge that converts Containerd capability to what Kubernetes does. I'm gonna come back on that later. And there are a bunch of Containerd made of services. There are the events, there are metadata like namespace, images, and containers, and all of them have a service that expose an API, and you can embed the API. So, and obviously there is a runtime manager, and I was speaking with somebody about Windows container, and this is where the magic happens. The runtime manager converts the request to something that all the runtime can understand. So when you are on Linux, you can use runc, which is the one that I told you before. But Microsoft made the Windows version, so when you work with the Windows container, you are actually using a replacement of runc, because everyone follows a standard that I'm going to tell you later. So metrics obviously are metrics because everything is metrics. You need to monitor them. You can use Windows to get stuff. Yeah, recently, not recently, but the last edition was all the imaging part. Containerd wasn't using images, wasn't managing images at the time, but they was bringing in the stack, so you can give container, pull images, and run them. And yeah, there is the snapshotter that are the storage and the volume part. So So as you can see, there is a lot of the overlapping with what Docker does, and this is obviously just because Docker used some of the capability, enriched the capability of the container. In Docker case, to be very human friendly, so the API that we use are great because there is a lot of work that we do. So Kubernetes is another, and embrace, like it's important for two different reasons. One, because itself is designed to be extensible, and that's the answer of the question about why everyone is using it. Because as a user, I can do whatever I want with the API, because I can build almost whatever. If I'm a cloud vendor, and that's why a lot of the cloud provider has Kubernetes offers, I can, replace all the layers with my implementation. So the VPC one was just an example, but there is also storage, so ADS or Elastic File System or all this kind of stuff. You can replace all the pieces, and you just offer the API that works, but you control all the stack without building nothing new. So, and yeah, so if you're not familiar with the architecture behind Kubernetes, it works in this way. You have a Kubernetes master that is the brain of the server, and you have a bunch of nodes that does what the master says. There is a daemon in the node that pull information from the master, and based on what the master says, they do it. There are obviously CLI tools. The kubectl is a CLI for the Kubernetes API. There is a UI, so the dashboard is the UI, but there are a lot of them, and you can read your own. So obviously there is an image registry where you can pull and push images, and all the nodes that you can imagine, so you can add hundreds. Inside every node, there is a kubelet that we saw in one of the previous graphs. And what the kubelet does is is the worker in the node. So the master knows what to do. It gets the request when you ask, okay, give me a new container, give me a new pod. The master reaches the kubelet and tries to understand where to place the container. Kubernetes starts to have a schedule. So it tries to understand if there is availability. If there is availability, it says, okay, this pod is going to be in that node A. So the kubelet in the node A takes the job and makes it real. How it makes it real? It creates DNS record in the Kubernetes DNS. It creates the pod, and to create the pod, it doesn't really know how to do that. It relies on something. And by default, or the default behavior is it relies on Docker. So kubelet speak with Docker. The Docker API are breached with a Docker proxy that translates Docker to Kubernetes stuff, and it gets applied down the stack. So you can see that by default, the stack is already kind of huge, because you have your Kubernetes, you have the kubelet, you have Docker, you have the proxy, the Docker proxy, and you go down to Docker, and Docker goes down to container D, and container D goes down to run C. So this is a big change, and that's why there are a lot of other implementations. That's why container D, for example, has its own proxy, so you can remove Docker from the chain to admit it and go deeper. And there are other projects that don't even use Docker; they just use runC, and they are built by default to be natively supported by Kubernetes. So I'm gonna tell you the name of the project later. But this is it. This is what I mean with extensible, and this is what I think we should have in mind when we pick a tool. It should work like this, and when we design a tool, our tools should work like this, or at least should be designed to be extensible or usable from function. So Docker for Kubernetes, as I said, is just one of the implementation. By default, we have Docker and we use Docker. Docker has this tiny proxy that does the translation. But the fact that there is a specification in the middle between what Kubernetes expects from the container runtime to do, you can build your own. So the interface is called a Container Runtime Interface, CRI. And Rocket is like one of the first, I think it was there even before Docker. CoreOS made it to run containers. So, and they made RKT-let. So it's the bridge between Rocket and the kubelet and the CRI to speak with Kubernetes. So back in the day when CoreOS you was using Rocket, and Rocket had this bridge, and you was using Kubernetes as normal, but under the hood you wasn't using it. So as I told you, Container CRI is the plugin that reads container with the kubelet, and Cryo is the one that I told you before, where it used ramc under the hood to speed up the actual container, but it doesn't have any bridge because it is the project itself. So Cryo is designed to work only with Kubernetes. So there is no bridge, it's a binary, and it's made by Red Hat. Probably I don't know because they don't tell me, but cloud providers and big SaaS has their own implementation. So I know, I can suspect that some of the cloud providers are using containerd looking at who contributed to the project, but who knows what Alibaba used. So we went in this old giant world of container and orchestration, which looks really complicated and far away from our journey. But everyone has a Jenkins installation, and when you use, I know you have one. So I have one, you have one, so everyone else has a Jenkins. And when you use the Docker, even if nobody's happy to tell you, I know you have one. So when you use the Docker Jenkins plugin, it doesn't do anything else that look for a container for Docker, for the Docker socket, or for the Docker TCP, whatever you configure, and it asks Docker to do the job. It's a bridge. So without extensibility, our world wasn't existing as we know it. So, and this is an example of what you can do. As I told you, I work in the SaaS offering. So we are on AWS, and we support a lot of regions. So our customers can go and can buy InfluxDB as a service in one of the regions. And we built the automation behind the request of the client. When we started this project, Kubernetes wasn't that big and famous, so we have our own Go code that does the work. Obviously, it doesn't do the work by itself. It relies on AWS API, it relies on the Docker API, but we are back in business of accessibility. This is how it works. There is a master. This will look familiar to you. There is a master that knows what to do, and it tells the node about what to do. So it looks like a Kubernetes one. It's definitely easier. It's definitely less extensible, but it works. And every time that a customer asks for a new cluster, it specifies the number of EC2 and how they look like. So the master spin up the EC2, it installs the worker inside using the user data, and it installs Dockers and everything. And the daemon inside every node knows who he is because he knows what to do. So he knows if it's a data node of InfluxDB, or if it's a meta node, or if it's a capacitor node, or if it's a Grafana node. So it says, okay, I'm a Grafana node. What do I need to do? And the server tells him, okay, if you're a Grafana node, you need to download the Grafana container, you need to expose the port 18, you need to expose the port 88, you need to mount those volumes, and all this kind of stuff. We combine the request, we push the request down to Docker D, and that's it. We don't even need to expose the TCP layer because we have this binary in every server that just speaks to the socket like the Docker CLI. Every cluster of the client looks like this one. So there is a security group, and the security group is the one that is a firewall that casts requests and says what the servers can do and will speak to us. So we have a bunch of DNS requests, and for every public exposed service, we have a load balancer in the middle. So all this kind of stuff is managed using API. So we have SkyDNS that is an old version of core DNS, so it's a private DNS that you install, it uses TCP, and you can configure it to solve that just normal DNS. So we have a DNS for every cluster to keep isolation. So we don't want the customer to share for any information or even DNS. And that's it. Every node has Docker and you know what to do. In this case, we use Docker a lot like process management, so like systemd. So run the containers and keep it alive or kill it or restart it. So it's nothing more than that. It's more like a system you replace. Another use case is for the extendability that is very famous when you do testing or this kind of stuff. It's the Docker Team Docker solution. So you can run the Docker image and you can share the socket, so the Unix socket that you use from your laptop. And from that point in time, inside your container, you are speaking with the Docker daemon in your laptop. So, and when you're done with that, you can remove the container and you get it started. So, and that's why when I'm inside a container, even if the Docker image is not an Arch Linux or doesn't have 15 gigabytes of RAM, you see that these values are from my actual laptop because the request goes to the socket is my daemon in my local environment, and I reach it. And you can go deeper and deeper how much you like. So inside that you can run another container and you can go deep and down whatever you like. So you can keep down the pain. So this is very powerful. I don't see this kind of implementation in a lot of projects that are not open source or new. And this is very cool. I mean, and the implementation is simple because the same flow that you have in TCP layer you can have in the Unix socket. So all the protocol is the same. It just goes to a Unix socket and not via TCP. But it's the same client, same stuff. So, and the good part is that it's locally. So it's secure as soon as your secure your virtual machine on your laptop is secure. So yeah, remember it when you design a software. This is I took it from Docker in Docker, but if you need to install, let's say that you need to install Jenkins inside a container. Those who want, and you install the Docker plugin, but to use Docker, because every Jenkins build we start inside a container. The Docker Jenkins plugin does that. Every build starts inside a container. So you kill the container, the job is done, and you're clean. How you do that? You run a Jenkins container, you share the socket from your local environment, from your node, and the Jenkins plugin will know where to look at. No? Yeah.
Sorry, I think this is more considered as Docker outside of Docker. Docker inside of Docker would be running a separate Docker daemon inside of the Docker container. Because you're communicating, if you volume up the Docker from the host, you're communicating with the Docker instance outside of itself. And that is
I mean, you can do both. I think that usually the common path is this one, the one that I saw most. So you speak with your local daemon, and you're there. But you can also do it the other way. And in that case, if you trash the Docker daemon, you keep is just fine. If you share the one. If you need more, you can expose the TCP version. So now it's not enough for you to use the Unix socket. So what you can do, you can say, okay, give me a TCP. You can configure Docker D to expose the TCP version. And from that point in time, you can reach that from the outside. Obviously, this is a security vulnerability. If you don't need it, don't do it. And if you do it, use your private network so you don't go to the outside. So be careful because from there they are now in the new. It's not released yet, but it's merged in the Docker master. So in the next release, probably you will be able to run Docker as a rootless daemon. So right now, when you run Docker, you need to run it as a sudo. There is a new request that says that you can run it not as a sudo. Obviously, if you need to go down and have more permission, you can do that. But if you don't do nothing, if you do normal stuff and nothing too crazy, it's good. So remember about that. You can use a rootless Docker. But in any case, just expose that to your private network because usually that's where you need it. You don't need it from the outside. I work in Go, so I'm confident with that. language, but there are SDKs for everything, and the Docker Jenkins plugin uses the Java version of it. But Docker has a lot of generated SDKs that you can use in your project to do whatever you want. But when I told you about our way to spin up and configure clusters in our cloud, we use this kind of code. This code is pulling an image using Docker. So it communicates to Docker, okay, give me the image from my application. But when you create a new client, you create client from different sources. The easiest one is from environment variable, because it gets all the Docker environment variable that you can imagine. Usually the most used one are the Docker house token or the Docker host. So you point by default the Docker host is the Unix socket. But if you are over TCP, you can do Docker underscore host equals TCP semicolon / URP, and the Docker CLI goes to that. You can do the same. It has the same behavior in the SDK. And this way, it's a magic way to say, okay, behave like Docker CLI. Use the same configuration. And yeah, you get the version of the API, and from there you're good to go. You can do whatever you do with Docker CLI, because Docker CLI just uses the SDK. So you can pull image, push image, authenticate, or you can run containers, delete them, keep them. You can do whatever you want in your application. Docker Swarm Kit in this scenario is another example of this kind of work. Everything started with Docker, but now we need orchestration. So what we can do, use Docker and build an orchestration on top of it. So just like Kubernetes, Swarm Kit is a library. They develop it. It's also really nice how Docker and the community works, because they have Docker, but Docker is made of different projects that I call it. They handle Kit. So Swarm Kit is one of the projects, but it is the VPN Kit. There is the lead network for hosts, so not Kit, name yet. But there are, if you look at the GitHub organization, there are a lot of Kit stuff projects, and all together they build what we know as Docker. So Swarm Kit, when you do Docker Swarm init, you are using the Swarm Kit library to instantiate an orchestrator. And the orchestrator relies on the Docker API. And yeah, if you are not familiar with how it works, it is an orchestrator. It's a distributed system that orchestrates containers. So you join the Docker DO together, and as just Kubernetes does, it says, okay, this node has availability to run my container, so place my container over there or over there. And if one stops, it goes restarted. How we end up having all of this stuff that works together so well? There is a lot of politics going on, and that's where the CNCF and the Cloud Native Foundation, Linux Foundation, and Microsoft, Docker, and all these IBM, all these giant companies are working together, building the specification to have this technology. If everyone was going by itself, it was way too messy. So I'm glad that we have that here. It requires a lot of work from other people. So CRI is the one that we saw, is the container runtime interface. So Kubernetes designed it to say, okay, I'm Kubernetes, I don't really care about how you run a container. I'm an orchestrator. So if you need, when I need to run a container, I use these methods. So implement them and we are cool. CNI is the same, but for networking. So if you are in AWS, you have VPCs. If you are in your laptop, you have overlay or breach. If you have in your laptop, you have breach. If you have more nodes, you use overlay. So container network interface is a specification that abstracts all these network capabilities in something that is common. Same for storage. I told you that there are a lot of cloud providers, and cloud providers has their own block storage, but how Kubernetes can mount persistent volumes from all of them. Just asking for the CSI contract for you. You know that the container storage interface is like that, and that's it. But going down the stack, there is the OCI, and the OCI has two of them. It's the runtime specification. So it's run C, the small binary that takes the description and makes a container. So this is the the down step. So down there, you can go down there. And there is also the image specification and that's why we have a lot of different registry that work so well together. Image registry, Quay, Docker Hub, Nexus from Java world. No, they all work with Docker because they all agree on the same image specification. And how you do all this stuff with images, and developer complains. So more they are good, more they complain. So it was a really gigantic work. What we have now, so with the image specification, we have a lot of projects, but probably the most famous one are Docker/build kit. So it's kit. When you do Docker build, back in the day, it was a bunch of code hacked in Docker itself. Recently, they released build kit. That it's a refactoring of the build process. What we get with build kit is okay. It's a better Docker build command, but you also have a standalone building library that you can use. Thanks. You also go.
It's speeding up.
That's it. So we also get a library that we can use by our own. So Jess Roselle made a really good tiny binary. It's called EMG. That it's a binary that builds images. It uses build kit, and it does that from a rootless perspective. So you don't need root. You are safe using it as an option. And what it does, it just builds containers. It just builds images, nothing more than that. You know, when they did build kit and when they released it as a stable version, they replaced Docker build with that. Scopeo is a Red Hat implementation, so it's a binary that just deals with images. So you can fetch manifest and see how the image is before even downloading it. So it's really powerful. CSI, Kubernetes persistent volumes. If you know a little bit about Kubernetes, you know that it runs on every cloud provider, and every cloud provider has its own block storage. And you can't really rely on the file system of your server because your server is going to die, and it's going to expire, it's going to be restarted, and you need to serve. And when you need to keep the data persistent, what you usually do, you take the volume and you attach the volume to the server, and you run on that, and you run on that volume. Obviously, when your stack is close to the VM, you mount the volume and you're good. But with Kubernetes, Kubernetes plays the container where there is availability and for it. And if it dies, it changes the server and place the pod in another place. So the volumes need to follow your pod in your cluster. And they need to follow it in the same way, no matter where you are as a cloud provider. So that's why there are container storage interface for almost every cloud provider. I just listed a bunch of them here, but there are a lot more. And all these links are from GitHub, so I'm going to give you the slide, and you can go there and have fun with that. I'm gonna speak about this DockerCon talk, talk dedicated to it because I really like the topic, but I think it's great. So, and this is another way that you can extend Docker. The library is a set of libraries that they are called the test containers. So if you go in github.com/testcontainers, you will find them for a lot of languages: Java, Go, Rust, PHP, JS, TypeScript. So it's there, and it's nothing more than a wrap around Docker SDK with a friendly API to be used in the test case scenario. And this is lovely. And when I discovered that when I was working with the Zipkin community. Zipkin is a tracer in Java. I'm not a Java developer, so that's what I got from that experience. And you know, they are using Zipkin use different backends, so it can store data to MySQL, Cassandra, Elasticsearch, and whatever you want. So to test all this storage, they was use this API because from inside your task, you can spin up a container, you can configure your client to speak with the Redis container or the MySQL container, and when you are in the tear down of the task, you remove the container. It's great. It just works with, it looks like a unit test, but you have containers, you can do integration, and they are really live and thin, so great. The API is so friendly, you create a container, and you can do get containers IP address, so you know the IPs of the container. It's great. And you get the container, the port of the container mapped, so you don't need to specify the map because it gives you a random port that is always available. It's great. And when you test it, you configure your Redis cache, in this case, the client, the SDK, whatever you call it, and with the port and address, you test it, do get, this is a Redis, to get the Redis, and there is a tear down, there is not a tear down. Well, there is a tear down that you just remove the container. So I'm going to show you how I do that in the Go version because I know it better. Because I currently maintain the Go version. So I made the Go porting of this stuff. So under the hood, I'm just using the Docker SDK as I told you. The piece of code that I showed you before when you do the new client from environment. It's just a wraparound around that with an API designed for testing. So you create the container. I'm creating the nginx container. I'm exposing the port 80 because that's where it runs. You get the container. You can specify to start it or to start it later. So when you get the container, I defer the termination. So the defer stays, okay, is the last call that a function made. So when the test is gone, just terminate the container. So when I have it, I take the IP of the container and I take the port and I make my test. So I just made my test with the HTTP client. I test if the HTTP status is good. You can check if the body of the request contains the nice HTML flag or whatever you want. And that's it. I love this. And that's not because I tried. Another experiment I did back in the day, it was an autoscaler for Docker Swarm. So Docker Swarm doesn't have autoscaling capability, and I was working with InputDB, so I was looking for a project to make these two stuff together, and I wrote a tiny binary that was wrapping the Swarm Kit API and was offering an easy way to scale up and down services. So Swarm Kit works in this way. You say, okay, I need a service, they call it service, that is a container, it's an X number of containers that looks like this. So I need 10 nginx, because nginx service. And the idea is that you can scale up and down those numbers based on the metrics. So this project is a very tiny one, doesn't do anything, it just exposes a better API, HTTP API to scale up and down. So when you have this running, other than doing the awkward, whatever you're doing the patch on the service with Docker Swarm, you just call this where the handler, the orbital, and this is the name of the service, and do up and down. Up goes up and down goes down. You configure how much time goes, how many containers spin up when you go up, and how many when you go down. And I don't even remember how it works because I wrote it 2 years ago. That's it. Well, yeah, I don't know for how much. I don't know.
No, good. All right, have a good time to questions.
Yeah, whatever you want. There is a lot here, so you can even start from something different.
You guys want to have a drink break and come back, or you find questions? Okay, fine.
I'm gonna have a drink.
Yeah. I'll let the cameraman again.
You have a master in that scale up. How do you get HA and you are a master? You can't choose the same. How do you get?
You are speaking about Kubernetes or this last example of each one?
Let's go.
Okay.
How do you make? How do you use Kubernetes to scale up a master?
Okay, to keep the availability of the nodes, Kubernetes nodes, I use for the master, what really matters in the Kubernetes master is that the etcd backend. Kubernetes uses etcd. It's a database, and it uses etcd. So the idea, if you can manage to have three etcd instances, you can have a lot more masters because it doesn't really care. So you keep the availability of the etcd, and at that point the Kubernetes status. So what matters is the availability of the storage. Etcd. Yes. Yeah, because when you configure Kubernetes, you say where is my etcd, and usually it's localhost. So you can do something really weird and say, okay, this is my node, and I'm gonna have a etcd and join etcd for every master. Or you can just say, I'm gonna have my gigantic etcd installation and point them.
So that's Go container, test containers Go. Do you write like, is that a container itself? Do you run and then
No,
that?
but you can run that inside a container.
Okay. How do you usually do it? You just run it and then it spins up containers using your.
I use the Docker in Docker, so I don't use the Docker Jenkins plugin. I use the Kubernetes Jenkins plugin. So every build is not a container, but it's a pod. But I use Docker in Docker, so I share my Docker socket, and Tesla test containers knows where the socket is.
So then the one pod will bring up other pods.
Yeah, in my case, it's containers. Yeah, test containers does with containers, but yeah, test containers create other containers. And it doesn't really matter where you are as soon as you can give in a Docker entity. So if you are inside a container and you share the Docker Unix socket, it's fine. If you are inside a container and you have or you can point it to a TCP Docker D, and it's going to start containers in that Docker D. So it's on top of it.
So, question on your SaaS product. So there was a slide, I think, where you explained a bit like services we use for the SaaS, and one was load balancer. What load balancer do you use?
Both Elastic Balancer version 1, HTTPS balancer, and the application of balancer.
Does it mean that you spin up per customer your own load balancer?
If they need isolation, for isolation we do ELB, so we spin up the DB1, so we spin up one. If they don't need that, we use application of balancer, so there is a limit of 100 rules per load balancer.
Yes.
When we have 100 rules for that load balancer, we get another. We use both because we started with the ELB and we moved from application balancer because it was cost effective.
So you weren't able to get basically limits.
They don't. No. I think I didn't mention.
Then this is your database you use underscaling for your Kubernetes nodes.
For the workers.
For the workers, but not for the so workers. So does it mean on the worker that's where the containers are hosted? How do you handle the case for let's say you have a node, right? And you have maybe or essentially the question would be then first, what method do you use to scale in?
Now we use right now we use autoscalers just to keep the numbers stable.
Okay.
We don't scale up and down.
Okay.
We just say no.
So that is one of the most difficult things that I have, which is why I simply didn't want to get this. This problem with use, like, let's say CPU-based metric scaling in, and let's say a node is going below a certain level, but there's still containers running on it. Then all the scaling process will just kill the whole node with all the containers. And it's fine, you have a load balancer, but by the time the load balancer picks up that it's not available anymore, you lost that value.
And Kubernetes is not easy as it applies. So it's like when I started, and everyone starts think about, okay, I'm gonna just run pods, and every node looks like the same, and it will be a fantastic thing. Not like that. We have a lot of autoscalers, and every autoscalers keep up a small set of nodes where we place some containers. So we have a bunch of nodes dedicated for Kafka containers. We have a bunch of nodes dedicated for our storage that is CPU intensive. Kafka is memory intensive. We have a bunch of neutral generic workers where we put whatever we don't know where to put stuff. So you end up having a lot of small isolated group of nodes, and it means that you can monitor them in a more traditional way.
So does it mean then, that's also just out of curiosity, does it mean then that you are actively having alerting, and then based on that you, I don't know, change the Terraform config to say, okay, add more? Or is that, or would you already have somewhere something in place that can automatically then, send an API request if this threshold is being held, and you do kind of auto-scaling but outside of
Okay, you have two layers of autoscaling when you are Kubernetes. You have the Kubernetes pod autoscaling.
Yeah.
Give me more pods. Give me more replicas.
No, I mean
pods.
the nodes. Because
No.
pods is like easy, but that's already handled by Kubernetes.
Yeah, we tend to use this. I didn't speak about that because it's completely different. But yeah, okay. The idea we are following right now, it's under development, so it's I don't know if it's gonna work, but it's an idea. So I write a bunch of blog posts, but there are no tools because it's just an abstract or something. But the idea is that there are two kind of resources. What we call short-term resources and what short ETL. There is a blog post about that in my blog, over there. What we call short ETL and what we call long ETL. So long ETL are resources that, for resources I mean everything you can think about. Pod, autoscaling, VPC, subnet, root DNS, single DNS record, everything is a resource. But there are short and long. Long are the one that doesn't really change or change really less frequently. Like VPC, subnets are there because you can't really change them that much. You can have a new one, but you can really change one. Short ETL are stuff that move faster. So pods, containers are short ETL. So for long ETL stuff, we use more traditional configuration management tools like confirmation in our case, in the Terraform. For short ETL stuff, we use API. So we recently, when we started our journey with Kubernetes, the autoscaling group wasn't just a commodity. We had one autoscaling group with 20 nodes, and that was it. So for us, it was a long ETL. But when we started to have a real cluster, and we saw that autoscaling was going to go up and down, it was going to be removed and replaced, and change labels and stuff, it got promoted to a short ETL kind of resource. So we stopped to manage it as a transformation, and we started to use it in ETL API. So we made a Kubernetes custom resource definition. The custom definition in Kubernetes are Kubernetes is so extensible that you can use it to manage whatever has an API. So you can proxy your AWS API inside a Kubernetes resource. So other than creating pod, cron job, or deployment, stateful set, we create autoscaling for AWS. And that's how we and inside as an autoscaler resource, we use the Amazon API. And there are no tools around that. It's something that I'm trying to be relatively defined because this is how it's working for us, and we are double checking tools. We use Kubernetes. We actually on AWS, but as I told something, Influx Cloud for us is a product, so we have a team. We invest on our SaaS. That's why we took that approach. Also because we like public. Yeah.
Sorry. there any plans on building on a multi-tenant product? So one that is not separated, but like a shared influx EB kind of.
We are
It's
working
an
on.
advantage, obviously, that it's going to be a bit cheaper.
We just released alpha, the alpha 2 of the version 2. So if you are following development, there is a version 2 that's coming. It's right now in alpha, and it is multi-tenant by default.
But will that also be a SaaS offering?
It will be a SaaS account, and that we are building it because it's way less in terms of cost and maintenance. Maintenance, I don't know, cost from to have a multi-tenant solution. So for customers that we need, we will have one or a bunch of the big clusters and we will multi-tenant. Well, the open source version of InfoDB 2 that is already available, it's not stable, so use it for fun, has multi-tenant built in. So when you start a service, you get, okay, give me your organization, give me your user and control. And from there you can create more organization, more users. Oh, now you know what to do this night. Like building integration.
Floor is open.
I said you presenting a talk on about this test container.
Yeah, it's not announced. But
Is that might go online?
So, quick question about this test containers. I think this sounds interesting. So, this is open to use in any language.
yeah, there are a bunch of libraries. If you go on github.com/containers, you see all of them, but all the one that somebody did. If you're using a language that it's not there, you can leave it. It's really a wrapper around it.
I've seen I use Python a lot. So on Python they have a Docker library where you can create containers
Yeah.
and things like that.
I think it's probably it's the same. It's not called test containers. I think what I really enjoyed was the idea and that programmatically configure your task. That's what triggered my.
So you create the image and before you push it, you write the test the image.
This is another stuff we do. We don't use test containers. We use test containers inside our not anymore unit test to manage our dependencies. So if my application uses MySQL, for example, and I would like to test how a query works, back in the day, usually you have a separate MySQL or something that gives you MySQL, you know the URL, and maybe it's a Docker Compose stuff. But if you embed the Docker CLI into your test, you can do that by yourself in the test itself. This is, I think, the main biggest change.
One container which is kind of what if you use like a whole bunch of
You can do whatever you want. I mean, you create multiple containers. You have more images, you have different IPs, you have different ports. You defer all of them, you terminate them, and they are gone. And this one is a basic example, but you can, if you need, let's say that you need Zipkin is that tracer, and Zipkin has its own dependency that is the database. You can create the database, you can get the MySQL container. From the MySQL container, you get the IP, and with the IP, you configure the Zipkin container with the IP of the MySQL as an environment variable. Because when you request a container, you have all the capabilities you can create. You can mount volume, you can embed environment variable, you can make that as complex as you like. Obviously, more complex you make it, there is concurrency, there is latency, there is your work. From here, actually, it's so far.
I had a question. I'm getting you to Kubernetes. I think my struggle was with system volumes. So
when you're working in a space where you don't have that volume available, is there any workaround if you don't really care about your data, but at least you want to be able to have two or more pods sharing the same volume? Is there a way where you can have one pod that captures the volume and they all point to it and they write to it?
There are not a lot of file systems that manage concurrent writes. So you're gonna, if it's a read intensive application, you can place the two content in the same pod and they will stay in the same place and you will share the same volume. So that
Because the problem I have now is that I have a pod that does testing and gets reports, but then that report exists within that container. When the container dies, it's not available anymore. The other thing is because I'm exposing the service so I can see the reports, when I scale my pods up so I can run multiple tests, the reports only exist within those containers.
If you should look at an object storage, like if you're on AWS, that's 3, but if you're not on AWS, there's a project called Minion. Minion is an object storage like S3, it's an open source project. It's compatible with S3 also, it has its own stuff. But the idea is that you need a place where you can place your files. So it can be a database, it can be an object storage file, but you can keep your stuff there because the model doesn't scale. It's an architectural problem from what I can see, from what you say. So keep a database and push your stuff in the operating database. What Jenkins does, it has, for example, a manifest sort of directory. So you load, when your test is done, you load the output in a manifest and you move that to Jenkins. So it's centralized. You should do the same, and you can use the centralized place. It can be whatever. It can be a database. It can be a Minion, S3 like object store, whatever its case. But I think that's the best like change that I can suggest. You can hack stuff together, but that's probably that solution.
So this open source medium is referring to. So within my cluster, what would that look like?
It will look like a separate URL, and from when your test is over, you have a file. You have the file.
File and just push it to the
You push the file out. You can see like a MySQL or whatever. So push that there and your application will run. This is a thing that the scalable suggestion I can give you. Probably there are hacks that you can do, like you can place containers in the same pod and one of the container watch for the file and move the file on volume. So you can hack stuff together to make it over, but to make it work, like that. Can be anything, another place where you push that.
So you've been operating under the premise that like containers are so volatile that we shouldn't use it for our database. So we're running our database on like its own Linux as a separate service that we access over TCP. Since you guys are running your Meetup on containers, what is your business system? Is it just the AWS offering with the system storage? And how reliable is it, or what challenges are there?
Yeah, luckily for us, we write the story. So we have the right guy that can make it all the containers. And we decided to run it inside a container because one of the purposes of the database, one of the goals is to be easy to run in a database. So that wasn't required. Probably Cassandra doesn't have the same kind of reputation or stuff like that. So, definitely having the people that run database in the company is great. The challenge we had with the biggest challenge we had is with persistent volume itself. They are not, sometimes got stuck. So they are not able, it really depends on the hypervisor where you are. So Amazon, it can happen that the pod goes out, Kubernetes reschedule another one in another node, but the volume is still attached to the old one, it doesn't get moved. This is getting better and better with a new version. So when we started 1 year and a half ago, it was happening all the time. What we are doing, we are monitoring for that situation. So when we see the kubelet that it's scanning a container, it triggers a particular error that says that it's not able to change it. So we have an automation that looks for the volume and forces the attach. Yeah. So we use monitor. Yeah. But as you said, it's a workaround, it's automation. We monitor for it and we automate for that. That's what we do. But it's getting better because persistent volumes are getting more used. So it's eventually maybe a hack, artificial hack. Sometimes it's just in this reliable world, sometimes you try just you have to try.
So we're running in a corporate environment, and it's quite difficult to figure out what's wrong with Docker when it doesn't work. Really look to see what's wrong with something that doesn't process it. How do you manage that? What do you look for? Like when you have the process service configured, everything's configured and whatever, and it still doesn't work with it. Like that kind of thing. And it's configured at all the levels you can. And I'm not learning it, so I'm going to take another one and download it. It doesn't work.
Yeah, to be honest, I'm not the right person to ask that. But yeah, because I never really work with big enterprises environment, so I guess so.
It's a name problem, right?
Yeah, I mean, yeah, I usually really all at an open. There are a lot of people that know that where to go maybe, but I look at the logs. I just usually I take the big hand and join the server. And that's my approach to everything. So that's how I work. That's how I work. Yeah, if it's a proxy, I mean, if it, I don't know.
Like network level stuff like RScan.
Yeah, you can use Wireshark or Traceroute or whatever. You just start, I say take the biggest tool you have and just try. You look at the network interface, you go there. At the end of the when you don't know where to go, we go to the network interface. Hopefully. So, I don't have I'm better at that. There is one of my friends is called Lorenzo Fontana. You can find him on Twitter, whatever, I can give you the name. He's really good with eBPF. I don't know if you are aware of that, but it's a technology that is inside the kernel, and it gives you it's like a VM, and you compile eBPF code in bytes code, and it runs inside the kernel, and it gives you metrics from the kernel using a map. So it sees a map and it's writing that map. So you run, it's like running user space stuff inside the container. And with that, you can do everything because you can scan everything's going on in the container, in the kernel itself, and everything that runs on it. So if you're really looking for the most flexible and deeper and awkward syntax, you can have a look at the eBPF. Netflix uses that a lot.
A lot of times stuff is freezes,
Yeah. You take the big hand and go there. That's how it is. I don't have any suggestions other than that. Everyone likes it, so you make it work. So I don't have more. I'm a really practical person. So. Yeah. But yeah, I can tell you a lot of stuff you already know them. So you configure Kubernetes to get all the logs together in a centralized place, and you configure your collector to take whatever you can take. With InfluxDB, we use that approach. We take whatever we can take, every matrix, even the most cardinality sensitive one. So even the one that generates a gigabyte of log an hour, or a gigabyte of data an hour, and we store all of them for at least 1 hour, 4 hours, or 6 hours. 6 hours. So everything goes there, and you have 6 hours to figure out what's going on. And everything is there. So when we see that a particular metric is important or we need them for more, we use capacitor to move and downsample the data to a new table. So InputDB works in this way. It has a concept of database. So you create a new database, and it has a concept of measurement. And measurement are like table in MySQL. They're not like table, but that's like the table. And every measurement has a retention policy. Retention policy can be, by default, is forever, but you can configure it. And it means that when your data, when your point is over the retention policy, it goes to the database. It's a way to clean up database by itself, because when you deal with time series data, usually you need that for 4 hours or for half an hour. Or you look at your dashboard in the now time period. It never goes back in the last year. So what we do, we use retention policy and we move the data from retention to retention, from 4 hours to forever. And we downsample them. So if we have 1 point for every second, in the 4-hour retention, maybe in the day we take the mean or the sum or whatever, we aggregate that in 1 point every minute or 1 point every 10 minutes. So the data goes less precise, but keep that. So this is what I can tell. It's not about troubleshooting. No, weird stuff. Not the answer of the question at the start. Yeah, you know where to find me there, so let me know. Yeah, thank you.
I have a question around using InfluxDB.
Yeah.
So, if
Okay,
I'm
did
running,
any general questions, doctor? Anyone?
Oh, wait.
Are you happy? Oh, wait, you got something.
You can go. I will start.
Okay. All right. So this is our advice. So next Docker meetup will be the 26th of March. It's the 6th birthday of Docker. So it's only 6 years old. So imagine that. All the stuff we're having, all the stuff we're seeing, all the projects, all of the ways to change the industry, the way we work.
It's about to start school.
That's
Yes, they work.
Yeah. We always have cake.
And the balloons came today, and the streamers and stuff like that. So we take drink, please come to the March. And also we need speakers. So the format for the evening is how do you Docker? It's all about the community now, back to you. Small 10-minute talk. Nothing fancy, doesn't have to be in depth, it's just 10 minutes. How you use Docker at work, at home. So like I said, there's a lot of guys who have home projects, got their Cody on Docker, got Raspberry Pi projects. So it's all about how to use Docker. So 10 minutes, please bring your name through. Every speaker will get a limited edition 6th birthday Docker t-shirt. So you will get something for your efforts. And yeah, so we're looking at about 10 speakers for the evening. And so any topic. From CI/CDs, development, they're setting up your local dev environment, whatever. How do you Docker? How do you use Docker in your day-to-day work and that's it. Then, before we go, we take time all about experts. Once again, the great venue, for sponsoring the drinks, the food, and again, Leslie Lowe. So, like I said, the last one, there's people that work, that's not here, that they don't know about. A lot goes into planning this stuff. So she's been great for us so far. She's done all the ordering, the drinks, everything. There you go. And yeah, so that's about it. So 26th of March is the next meetup. Please submit your